Okay, so what we are doing today, it's going to play into the fact that we are given radians and we are given degrees, okay? What we need to find are these three functions: sine of something, cosine of something, and tangent of that thing. Okay, first of all, I want to point out one little symbol right here, okay? This little guy, in fact, I'm going to draw him up on the top of my paper. Okay, this is actually a Greek symbol. Theta. Theta. It is not 0. It literally just means x. It is another variable. Okay?
Why?
Because they thought we didn't have enough variables. We didn't have enough symbols in math, so they threw in theta.
Make us look more scary.
Mm-hmm.
Why?
They went to Greek mythology.
Okay, so don't let it freak you out. This is the same thing as saying sine of x. It's just sine of something we don't know, or sine of that thing. Okay, so numbers 1 through 4 are actually just review. Okay, we've already talked about finding sine, cosine, and tangent of an angle. So let's remind ourselves how we do that. Okay, so under theta, remember how we find the functions. We have so, ca, and toa.
Still doing that?
Yep, still doing it. Sine, cosine, and tangent. Sine goes with our opposite and hypotenuse. Cosine, adjacent and hypotenuse. Tangent, opposite and adjacent. Okay? Those are not going to change. So let's go ahead and look at number 1. Okay? Because this does take it up a notch a little bit. Okay? And you'll see why. So this is saying sine of theta. Okay? Don't let theta fool you. It's just telling you where you're standing in the triangle. We're standing right there. We're standing at theta.
We're standing at theta. What about fate?
Okay, so this is actually kind of nice, these examples. It only gives you the sides that you're working with. So sine only deals with opposite and hypotenuse. Okay, it only gives you opposite and hypotenuse, but tell me which is which out of 22 and 13 root 5. Which one's my opposite side? Which one's my hypotenuse? Who thinks they got it? Which one's my opposite and which one's my hypotenuse?
Hypotenuse is 3 over 15.
Ooh, right here, 13 root 5. Yep, so that is my hypotenuse, right? Always across from the right angle, which means my opposite from theta is 22. Okay, not too bad, not too bad. That's kind of nice. We don't even care about the adjacent. It doesn't even give you it. Okay, so sine of theta, just like our last unit, sine of theta equals opposite 22 over hypotenuse 13 root 5.
We just do this.
So here's the thing that makes this complicated, you guys. So here, there's a rule in math. Just like we can never have 0 divide by 0 on bottom, for some reason, mathematicians hate having radicals on the denominator. So this root 5, we got to get rid of it. Okay? It's not too hard. What we're going to do is we're actually going to multiply the whole thing by root 5 over root 5. Okay, this is called rationalizing. So if it says rationalize your answer, it means do this little step right here that we're doing. Okay, so it looks a lot more complicated than it actually is. Let's go ahead and work up with the numerators first. 22 times root 5 simply turns into 22 root 5. You literally just push them together. You don't even have to multiply numbers or anything. You just put them together. The denominator, it looks kind of scary. Okay, but root 5 times root 5 simply turns into 5 because these guys cancel each other out. You're just left with what's inside. So now tell me, now we need to multiply 13 times 5. Somebody help me out. I'm not going to tell you the answer. You need to tell it to me. What is 13 times 5? What does that give me? What'd you get? 13 times 5. Gabe. Beautiful. And there's our answer. It's super ugly. Okay, but that's okay. Remember, numbers can be ugly. In fact, once you get to higher maths, numbers are super ugly. Okay? Cool. Alrighty, so let's try it again. Maybe this one will be a little nicer. Okay, so we have, ooh, actually, this one is not nice, and I'm actually going to change it here. Instead of tangent of theta, I'm going to go ahead and change it to cosine of theta. You're going to thank me for this. Yes, yes. Okay, well, again, we're just standing at theta, standing at this side right there. Now that I changed it to cosine of theta, we need adjacent, right? Since it's cosine, adjacent, and hypotenuse. But which is which? Out of 6 root 3 and 12, which is my adjacent side and which is my hypotenuse side? Which one is my hypotenuse, 12 or 6 root 3? 12, beautiful. 12 is my hypotenuse. That means 6 root 3 is my adjacent, right? The side that's closest to where I'm standing. Okay, so now we can go ahead and write our cosine function. So cosine of theta equals adjacent 6 root 3 over my hypotenuse 12. Okay, now answer me this, you guys. Do I need to rationalize this? Is the radical on bottom? Is the little square root sign on bottom on the denominator? No, it's not. So guess what? We don't have to rationalize. This is our final answer. Nice. We only have to do that funny little step when the radical is on bottom.
Oh.
Can I take all percentages?
You can at the end. Okay? Number 3, I'm going to change this as well.
To tangent.
Okay, this guy we're not going to talk about for a minute. Yes, I'm going to change this guy to tangent of theta. Okay, well again, we're standing at theta, right there. If we're working with tangent, that means I need my opposite and adjacent. Which is which though? 7 or root 15? Which one's my opposite and which one's my adjacent side? Who thinks they got it? Which side's my opposite? Which one's my adjacent?
7's the opposite.
Beautiful, beautiful, which means my adjacent is root 15. Great job. Okay, so let's go ahead and put it together. We have tangent of theta, not tangent of 0. That is not 0.
Oh.
Tangent of theta equals opposite 7 over adjacent root 15. Tell me, you guys, do I need to rationalize this?
Yes.
Why, Eli? Because what's on bottom?
15's on the bottom.
We have our little radical. Square root of 15 is on bottom. Annoying. That's okay. Rationalize, meaning multiply by whatever it is inside the radical, root 15 over root 15. And you're like, why can I do that, Miss Campbell? What is the rule that makes us able to do that? Because this, technically, you guys, as ugly as that is, that's multiplying it by 1. And remember, multiplying it by 1 doesn't change it. We're literally just changing the way it looks. Okay? Not the actual answer. Okay, so numerator is really simple. 7 times root 15 simply turns into 7 root 15.
7
And the denominator is actually really simple this time, you guys. Root 15 times root 15. Okay, well, remember, those guys just cancel out. You're just left with what's inside. So, 15. So our final answer, 7 root 15 over 15. Nice and pretty 15.
15.
Are they like the same as those?
Yep, those guys are technically 7 over root 15 is the exact same answer as 7 root 15 over 15. Just written differently. Think of it like 2 times 4 is the exact thing as 8. But which would mathematicians rather have? 2 times 4 or 8? 8. Yeah, exactly. Beautiful. Alrighty, I am going to change number 4 as well. Okay?
It's gonna be co.
Nice. Okay, I'm going to make it easier on you guys. Okay, this one I'm going to change to cosine Eli's a step ahead of me. So this time cosine of theta. Okay, I'm standing at theta. Cosine of theta equals adjacent. Ooh, I haven't labeled these yet. Which is which? Which side is my adjacent side? Which side's my hypotenuse? Out of root 13 and 7.
What's the
7's the hypotenuse and 13's
Look at that. So you guys remember.
Shoes.
I don't. You can go next door and see if they do. I can get some once I'm done teaching. Okay, so cosine, adjacent over hypotenuse. So we have root 13 over my hypotenuse 7. Do I have to rationalize that answer? Why not? Why don't I have to rationalize? Why, Gabe?
13 on top.
Love it. My radical, my little square root symbol's on top. So this is my final answer. For some reason, we don't care if they're on top. We just care that they're on bottom. Don't know. Okay. Show me a fist to 5 on numbers 1 through 4. Just finding cosine, sine, and tangent of theta. Nice, nice, nice. I like it, I like it. Okay, those of you guys watching videos or zoning out, show me a fist to 5.
I've zoned out a few times in this class.
Okay, okay. Continuing to zone out. That's fine. Your grade, not mine. Alrighty, okay. Look at numbers. We actually have 5 through 12. There's a lot of practice ones. I don't know if we'll make it through all 8 of these examples. That's okay. Whoa. What in the heck are we even talking about with this little swirly thing? Okay. Remember last...
On a screw.
Kind of, yeah. We're going in spirals. Do you guys remember last time we filled in the unit circle? Okay, well, turn your paper over. Let's go ahead and review kind of what last time we talked about. And no, we're not going to spend as much time as we did. Okay, but in this blank space on the back of your paper, okay, we have, let's go ahead and give ourselves a little unit circle. Okay, and we'll just highlight the bullet points right here. This first spot is either 0 degrees or 360 degrees. Okay, and remember we're going counterclockwise. Okay, we're going this way. That's why the arrows you're seeing are always going counterclockwise. Okay, once you hit that next little line, this guy is 90 degrees. Then you're gonna go another 90 degrees, which means this spot right here is 180 degrees. Okay, you're gonna go another 90 degrees. This spot right here is 270 degrees. Okay, cool. Alrighty, those are the bullet points. Now, a couple things we need to remember from last unit. You guys remember our special right triangles? Kind of? Okay, good. Let's go ahead and review them. Okay, remember, we know, or we have at least talked about 2 different special right triangles. Okay, give yourself a right triangle. Our first one is our 45, 45, 91. Okay, remember the sides of our 45, 45, 90 are 1, 1, and root 2. Okay, that was our first special right triangle, 45, 45, 90. Hence the angles. Okay, our second special right triangle, okay, is our 30, 60, 90 special right triangle. Okay, this one's probably a little bit trickier to memorize. I have a few different memorization tricks. Okay, the side closest to your 30 degrees, think the 3's have to go together. It's a little weird, but it's root 3 for that side, root 3. Okay, this guy turns into 1. And our hypotenuse is 2. Okay, here's where we're throwing you a curveball now with this new unit. Okay, they're like, oh, that's way too easy to remember those sides. For some reason, in our unit circle, that reason being that it's literally just 1 unit. These guys are now all divided by 2. Every single one of your sides is now divided by 2.
How?
Because in a unit circle, it's only 1 unit, which means we now have to divide all these guys by 2, or divide them in half. So divide by 2, divide by 2, divide by 2, which just turns into 1. Because 2 divided by 2 is just 1.
1,
And
that's a big curveball.
it's a curveball. Okay, but just have this on the back of your notes. Okay, it's literally just, okay, I can reference that. So we've talked about our unit circle, okay, our degrees in a circle, and then we reminded ourselves about our special right triangles. So let's go ahead, turn your paper back over, and let's look at number 5. What in the heck are we actually even trying to do here? Okay, so cosine of theta. So let's make a little note. Cosine still tells me I'm going to have to use ca. We don't care about so or toa. We just care about ca. We know we're going to have to use that guy. Okay, so if you'll notice, you guys, look at the picture. It's telling you that this is 390 degrees. How many degrees is a full circle? 360. Okay, so if that was 360 degrees, but we want to go to 390 degrees right here, how many more degrees did we go? From 360 to 390. How many more degrees is that, Gabe?
30.
Ooh, how much is it?
30.
It's 30. Okay, 360 to 390. That means this little theta right here, okay, everybody draw yourself a little right triangle. Okay, and I know it's small. That's okay. This little angle right here is 30. There's no way you can actually see that. It just looks like a little blob. That's 30. Okay, but guess what?
The other one says 390, right?
You what?
The other one says 390.
390, 360. Yeah, sorry.
I was making sure I read that right.
Yep, you got it. Okay, well now what we can do here, you guys, is we have a special right triangle. Okay, so if you refer back to the back page of your paper, this guy, this little triangle I drew here is our 30, 60, 90, because we just know that that's 30 degrees. Go from 360 to 390 is 30 degrees. Okay, well now I can label these sides. My new side of the hypotenuse was 1, right, because 2 divided by 2 was 1. I'm getting these sides from this right here. These sides right here. Okay, the side closest to my 30 degrees turned into root 3 over 2. Okay, kind of messy to see, but that side is root 3 over 2. Again, just these sides that we drew on the back of our paper. And then this other side right here, 1/2. Okay, I'm even gonna make this triangle a little bigger over here so we can see it. So I'm just drawing this again over here. So we have our 30 degrees in right there, 60 degrees right there, 90 degrees right there. This side is root 3 over 2. Our hypotenuse is 1, and our other side was 1/2. Cool, cool, cool. Alrighty. If we're standing at theta, which is right here, 30 degrees, we know that's theta, okay, because that's our angle that we drew. That's the little circle, squiggly. I need my adjacent over my hypotenuse side. Well, which side is my adjacent and which side is my hypotenuse in this triangle right here? Which side, based on where I'm standing, is my adjacent and my hypotenuse?
So 30 is hypotenuse, 60 is no 30 is adjacent, 60 is hypotenuse.
Very, very close. Our hypotenuse we're gonna need, right? Across from our right angle is 1. It's our hypotenuse. The side that's closest to our, where we're standing, 30 degrees, is our adjacent right there. Okay, now that I know those two sides, I can do cosine of theta. Cosine of theta, adjacent, root 3 over 2, over hypotenuse. Do I have to write over 1, you guys? Is that going to change my answer in math?
No.
Nope. So guess what? There's my answer. Root 3 over 2. Whoa. Crazy. Okay, let's go ahead. Skip number 6. Let's go ahead to number 7. It's a little nicer than number 6.
Whoa.
Alrighty. This, yes.
The arrows kind of looks like a V.
Yeah. Alrighty.
45 to 45.
Okay, so what's nice about number 7 is we don't have to figure out what theta is. Oh, it actually wants cosine. And I'm going to change it up. Just to throw us a curveball, let's go ahead and do sine of theta. Why not? Why not? Okay, so again, what's nice about this, guys, we don't have to figure out what this angle degree is. Okay? It tells us what that angle degree is. How many degrees is that? Okay. So now I'm going to draw my little right triangle here that goes down to my x-axis.
Oh.
And I'll draw it bigger over here so we can see it. Okay, there's my right angle. This guy is 60 degrees, which means that one is 30. Yup, and there's our special right triangle again. Okay, the beautiful part, the sides of this special right triangle, when you identify which one it is, they don't change. The side closest to 30 has your root 3 in it, so root 3 over 2 is that side. Okay, the side closest to 60 is 1/2, and your hypotenuse is 1. Cool, cool. It is math. It is crazy math. You guys are doing really hard stuff right now. You should be proud. Okay, so if I want sine of theta, or sine of that 60 degrees, I need opposite over hypotenuse, right? If I'm using sine, I need to use so.
So,
Looking at my triangle over here, if I'm standing at the 60 degrees, because that was my theta, which side is my opposite? Which side is my hypotenuse?
One half is
Ooh,
One half is hypotenuse.
one is the hypotenuse, right? Across from our right angle is always the hypotenuse. Which one's my opposite from where I'm standing?
3 over 2.
Uh-huh. Okay, so sine is opposite over hypotenuse, so root 3 over 2. And now do I have to write over 1?
no.
Nope, you never have to write divided by 1. That's not going to change your answer. So final answer, sine of theta equals root 3 over 2.
Well,
Yes, Donovan.
but you can write one every one.
Could you write divided by 1 under it?
No.
Was that your
Yes.
question?
No, I said that. That's well, but you can write one if you want to.
Yes, you could. It would be really ugly. It would look like this. Root 3 over 2 divided by 1. That's really ugly. That's why we don't like writing it. Okay. Yep, they're lazy. Okay, so let's go ahead, you guys. I actually want to skip 6, 8. I want to do some examples on the back. So go to the back of your page, okay, because I know you're going to see one like this on your assignment here in a minute. Let's say I want tangent of theta. So we'll just say this is an extra example. If I want tangent of theta, but theta is, let's see, I want to give you a radian this time. Pi over. No. Pi over. Ooh, okay. So this time it's not giving you a picture of the little spirals, and it's not giving you degrees either. Okay, it's asking for tangent of theta of pi over 4. Okay, so what we need to do, we need to convert it to degrees. How in the heck do I go from radians to degrees? Look up at our board. What do I multiply it by? It was numbers, the last two. What do I need to multiply this guy by?
2 over 2.
180 over pi. I want this in degrees. That's going to help me decide which special right triangle I'm going to use. What happens to my pi's now?
Gone.
Gone. They cancel.
They were sold.
Okay, now all you guys got to think here is what is, if I were to multiply it straight across, this would be 180 divided by 4. What is 180 divided by 4? Somebody help me out. I will not tell you the answer. What is 180 divided by 4?
45.
Nice.
Oh. 45.
Look at that, you guys. Okay, so here's what we're working with. Here's what this actually looks like in a picture. Okay, we've been given 45 degrees right here. Boop, boop. There's our special right triangle of 45 degrees. Oh, we know the sides of a special right triangle of 45 degrees. Just these guys right here. Okay, so now put them up on your special right triangle. Hypotenuse was root 2 over 2. Yes, that's ugly. Root 2 over 2. Your other side's 1/2 and 1/2. Okay. Boom. Lots of steps here. First, I converted it to degrees. Then I know from my degrees, it's a 45, 45, 90 triangle. Boom, boom, boom. There are my sides. Okay, if I want tangent, that means I need TOA. Which sides are my opposite and adjacent based on where I'm standing right here? 45. Which sides are my opposite and adjacent sides based on where I'm standing?
1/2 is.
Oh, it's gonna be 1/2, 1/2.
Good job. So this 1/2 is my opposite. This 1/2 is my adjacent. Okay, now here's something kind of funny that happens here. So tangent of theta equals opposite 1/2 over adjacent 1/2. What in the world?
1/2,
This is
1/2.
crazy.
This is crazy, but you guys know how to divide fractions. They taught you how to divide fractions in like 5th grade.
It's a whole, isn't it?
Okay, when you're dividing a fraction, what you're actually doing here is multiplying by the reciprocal. Remember that? Switch the second one. 1/2 times 2 over 1. That's the same thing as dividing by a fraction. Okay? Well, let's go ahead and just divide this out.
No, it's not a whole.
1 times 2, my numerators is 2. My denominators is also 2 times 1, which is 2. Tell me, you guys, what does 2 over 2 reduce to? Or what is 2 divided by 2?
It's a whole.
It's 1. So for this extra example, tangent of theta equals 2 divided by 2, which is just 1. And you're like, we had to do that much work to get tangent of theta equals 1? Yep. Whoa. Okay. This is like legit stuff. So show me a fist to 5. How are